Hi everyone, it's Miss Costa here, and in this video we're going to go through the November 2017 paper 2 for Edexcel Foundation. Okay, so this first question is asking us to write a fraction as a decimal. Now the key thing to note is whenever I have a fraction, I've got the numerator, which is the number on top, and the denominator, which is the number on the bottom. And this line here actually means divide. So it means 7 divided by 100. Now you might know your hundreds, tens and units columns, in which case 7 over 100 is the same as 7 hundredths. So if you've got your decimal point, you've got your tenths column here and your hundredths column here, and you could just write 7 over 100 as 0.07 because there are 7 hundredths. But if you're not too great with your hundreds, tens and units, the other way, as this is a calculator paper, you can literally just type into your calculator. Either you recognize that 7 over 100 is 7 divided by 100, so you type 7 divided by 100 into your calculator, or you can use the fraction button. So the fraction button is over here, and it allows you to just write your fraction in. So you write 7 over 100, and it will then just tell you 7 over 100. That's when you press format, and then you go down and you choose a decimal, and it automatically turns it into a decimal for you. So that would be 0.07 as a decimal. There's lots of ways to do this. You just want to pick the way that works best for you. For the next question, we're being asked to write down a multiple of 6 that is between 40 and 50. Now a multiple is literally any number that is in the numbers times tables. So the multiples of 6 would be the 6 times tables. So what you can do is just write out the 6 times tables. It's a calculator paper, so you can even just use a calculator to do that. So you've got 6, 12, 18, and the way to find the 6 times tables is you just add 6 each time. So 6, 12, 18, 24, 30, 36, 42, 48, and then 54. And now it's asking you to write down a multiple that is between 40 and 50. So the ones that are between 40 and 50 would be either 42 or 48. So you just need to write one of those, and that's all you need to do for this question. Next, we've got simplifying algebraic expressions. So it's really good to just actually write it back to its base algebra so that we can understand what's going on. So whenever you've got a number and a letter next to each other, there's this, say 3F, there's this invisible algebraic, oh, why has it stopped me from writing? There's this invisible algebraic multiplication glue. So you can imagine it just says 3 times F. Whenever a number and a letter are next to each other, it means they're being multiplied. So if I wrote this out as its base, most original form, it would be 3 times by F times by 5 times by G. So what I want to do here is I want to multiply the numbers together. So I've got 3 times 5, which gives me 15 times by F times by G. And then in algebra, I don't write the multiplication signs. So to simplify it means write it without the algebraic multiplication signs. So I just simplify that to become 13FG. So with questions like this, when you're multiplying, you multiply the numbers together and you multiply the letters together. And when you multiply letters together, you literally just write them next to each other, and that implies they're being multiplied. Now for the next question, you've got another simplification. And when you're multiplying the same thing by itself, that's when it becomes a square number. So anything multiplied by itself, anything multiplied by itself becomes itself squared. So for instance, if I did 5 times 5, that's the same as saying 5 squared, which is 25. So if I follow the same logic, I can apply it to algebra. So therefore t times by t is going to give me t squared. For the third one, I'm simplifying, and it's in a fraction, so it's a little bit trickier, but I'm adding collecting like terms. So when I'm collecting like terms and I'm adding or subtracting, I bring together all of the algebra that has the same letter. So 2n plus 6n, if I'm adding or subtracting, I could imagine it's an object. So n for, I can't think of a object, n for I literally can't think of something beginning with N. Let's just say N for nice bracelet. So you've got 2 nice bracelets and you're adding 6 nice bracelets together. So that would give you 8 nice bracelets in total, and that would become 8n divided by 2. And when we've got fractions, or when we're dividing anything by 2, we just divide the number. So 8n divided by 2 would give me 4n. Next, we've got a numeracy problem. So Ken buys some fruit. He buys apples, bananas, peaches, and oranges. He buys 4 apples weighing 125 grams, 2 bananas weighing 170 grams, 3 peaches weighing 135 grams each. And each orange, I don't know how many oranges he's bought, but I know that each orange weighs 90 grams each. And the fruit that he buys has a total weight of 1.785 kilograms. So I need to work out how many oranges he buys. First, let's look at the information we've been given. So I know he buys 4 apples and they weigh 125 grams each. So when you know the weight or the cost of something and you're trying to work out how much 3 lots of it or 4 lots of it are, we multiply. So as it's a calculator paper, I can just type that into my calculator. 4 times 125 grams gives me 500 grams in total. Then he buys 2 bananas, which weigh 170 grams each. So the total weight of the bananas is going to be 170 times 2, which is 340 grams. Then he's got 3 peaches at 135 grams each. So I'm going to do 3 times by 135, which is 405 grams. Now I know that the fruit has a total weight of 1.785 kilograms, and I could turn that into grams to make my life easier. So a metric conversion fact that you should know, if not then write it down, is that 1 kilogram is equal to 1,000 grams. So that means to turn kilograms into grams, I'm going to multiply it by 1,000. So I've got 1.785 kilograms, and if I multiply that by 1,000, that would give me 1,785 grams. Again, you can do this on your calculator if you need to. So I know the total weight is 1,780 grams, and I know the weight so far of all the objects that I have would be 500 plus 340 plus 405, which is 1,245 grams. So all the fruit that I know about weighs 1,245 grams, and when you include the oranges, it weighs 1,785. So I can do a subtraction to figure out what the difference is. So 1,785 take away 1,245. Again, I can just do this on my calculator. 1,785 take away answer. So a quick trick, if you didn't know, is instead of entering the last thing you have in your calculator, you can just press answer. The calculator remembers it for you, just a little bit less working. That gives me 540 grams. So I know that all of his oranges weigh 540 grams. I know that 1 orange weighs 90 grams. So to figure out how many oranges there are, I need to figure out how many lots of 90 go into 540. So I'm going to do 540 divided by 90, which gives me 6. So he has bought 6 oranges. Okay, now I'm told that Jane wants to buy 15 tomatoes. She asks for 1 kilogram of tomatoes at a shop, and she assumes, so when you assume something, it means you don't know all the information, you're just like, oh, I think that's what it is. She assumes that each tomato has a weight of 75 grams. If Jane's assumption is correct, will she get 15 tomatoes? So 15 tomatoes, and she's assuming they weigh 75 grams each. I'd do 15 times by 75, which is, 15 times 75 is 1,125 grams. So if she's correct, then no, she can't, because 1,125 is more than 1 kilogram, as 1 kilogram is 1,000 grams, and 1,125 is greater than 1,000. That sign here just means greater than. It's good if you can use that, but if not, then you can just write it down. If Jane's assumption is not correct, could she get 15 tomatoes? Well, if the tomatoes weigh less, and let's figure out how much less. So 1,000 divided by 15 is 66. So 1,000 divided by 15 is 66.6. So if the tomatoes weigh less than 66 grams, or 66.6 even, then yes, she could. So to justify my answer, I figured out the total weight that she wants is 1,000. She asked for 1,000, she wants 15 of them. And in order to get 15 that weigh under 1,000, you have to see how many lots of 15 fit into 1,000. Okay, so here we've got a table, and we're told that 60 students were asked how they get to school, and the table shows the results. And we're asked what fraction of the 60 students did not walk to school. So it's a fraction, so you always have your total as your denominator, and then like the thing you're being asked about as your numerator. So we know that our denominator is going to be out of 60 because that's my total. And then I'm asked what fraction of the students did not, and whenever they put words in bold, it's because people commonly make a mistake, so it's like highlighting a flag for you to read it very carefully. So what fraction did not walk to school? So we know 27 of them walked, so that must mean that if I did 60 take away 27, that's 33 of them did not walk. So I'd write that as 33 over 60. I could have got that by either doing 60 take away 27, or I could have added 15 plus 12 plus 6. And that would have given me the same answer, just depending on what you wanted to do. Then I've got a pie chart, and I am asked to complete it. So when you want to complete a pie chart, the key thing you want to remember is that angles in a circle add up to 360. So angles in a pie chart sum to 360 degrees. And we were told that, how many people were we told? There was in this table, the total amount of people are 60. So there's 60 people altogether, and we want to fit 60 people into equal sectors in my pie chart. So what you do first, whenever doing a pie chart, you're always going to do 360 divided by your total. So in this case, I'm going to do 360 divided by 60 in order to figure out how many degrees one person takes up. So 360 divided by 60 is 6 degrees. So I know that one person takes up 6 degrees on my pie chart. So then I've got, they've already done the bust for me. So 15 times by 6 is 90 degrees, and they've already done that one for me. So I just need to do 27 times by 6 to figure out how much, what degrees the people that walk are, 12 times 6, and 6 times 6 for the bicycle. So 27 times 6 is 162 degrees. And the great thing about this question is, even if you can't, there are so many marks that you can pick up, even if you can't get to the very final bit, even if you don't draw your angle perfectly. So that's why it's so important to show you're working. So 27 times by 6 tells me that the people that walk are going to take up 160 degrees. Now, when you do a pie chart question, you make sure you line up your protractor exactly over here, so the 0 sign is there, and then you go across. You start from 0, so you need to be very careful as to whether you start from the left. You're always starting from the 0, and you go across to where it is. So 162 degrees would be like this. I'd label it 162 degrees, and that's for the people that walk. Then I'm going to do how many people drive a car. So 12 times 6 is 72 degrees. So I know that 72 degrees, and you'd obviously measure it accurately. I'm on an iPad, so it's a bit trickier. Would take the car. And then for the final bit, 6 times 6 is 36 degrees. So I'd label that as 36 degrees and bicycle. So that's how you make sure you've done your pie chart fully accurately. Another way to double check that you've done everything correct is to add all of your degrees together. They should all add up to 360. If they don't, that's a warning sign something's gone wrong. Also, if you do your pie chart and you realise that you've got space left over, that shouldn't happen. So you want to go back and check your work again. Okay, I'm told that Annie and Lily share some money in the ratio 4:3. What fraction of money does Lily get? So with ratio, it's sometimes helpful to just draw it out to try and visualise what's happening. So let's say for every £4 Annie gets, Lily gets £3. So in total, each time they share their money, there's 7 parts in total. So as a fraction, this ratio is going to be out of 7, and Lily gets 3 out of those 7 parts. So that's how you can easily turn a ratio into a fraction. You're always going to have your denominator is going to be the total of your ratios added together, and then the numerator is going to be the thing you're focusing on. Okay, Rosie and Dan share some sweets. Okay, so that's 2 different people. So different, don't need to look back on that question. And Dan gets 1/4 of the sweets. So let's think about this again. So we've got Rosie and then we've got Dan. And Dan gets 1 out of 4 sweets. So Dan gets 1, and I know there are 4 sweets in total. So to make up 4, I'd do 1, 2, 3 for Rosie. So now I need to write down the number of sweets that Rosie gets to the number of sweets Dan gets. When I write ratio, you always do the first thing that's mentioned first. So Rosie is going to be 3 parts to the 1 that Dan gets. So your ratio is just going to be 3:1. Next, we've got a prime number question. So Steve says there are more prime numbers between 20 and 30 than there are between 10 and 20. You must show how you get your answer. So just as a recap, the prime numbers are numbers that only have 2 factors, 1 and itself. So 1 and itself. And the first few prime numbers that you hopefully know off by heart, if not, write them down and memorize them, would be 2, 3, 5, 7, and 11. So to check what your prime numbers are, 2 is the only even prime number. So that means that if there's any other even number, it's not going to be prime. 2 is the only even prime number in the universe, in any kind of number you could come up with. So 2 is the only even prime number. So let's try and write down what the prime numbers between 10 and 20 would be. So I've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then I've also got 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. And I need to decide which one has more prime numbers. So automatically I can cross out any even number, because that means they are in the 2 times tables, and that means that they will have more than 2 factors. For instance, 10, it has a factor of 1 and 10, but also 2 times 5. So that's why no even number will ever be prime, because it will have itself times 1 and then also 2. Then I can do anything in the 3 times tables. So if you know your 3 times tables, we know that 15 is the only one left over, and then 21 is in the 3 times tables, and 27 is in the 3 times tables. And lastly, you can cross out, so you always try your 2 times tables, then your 3 times tables, then your 5 times tables, and your 5 times tables has already been crossed out over here, 15. And that's going to be anything ending in 0, which will automatically be crossed out by you crossing out the even numbers, and then 5. So anything with a 0 or 5 is not going to be prime, because it will be divisible by 5. Oh, it rubbed it out completely. I didn't want that to happen. Okay, so then let's see what's left over. So between 10 and 20, I have 11, which is prime, 13, which is prime, 17, and 19. And between 20 and 30, I've got 23, which is prime, and 29, which is prime. So is Steve right? No, there are 4 prime numbers between 10 and 20, and only 2 prime numbers between 20 and 30. So there are 4 primes between 10 and 20. So that's how we do that question. You also might want to, if it's a larger set of numbers you're having to choose the prime between, you want to see if it's divisible by 7. And that's how you can check your prime numbers, really. Okay, so now I've got a scatter graph, and the whole point of a scatter graph is that you've got your y-axis and your x-axis, and then you just plot random points wherever they are to see if there's a trend or any kind of correlation, which means a relationship between the two things that you're comparing. So here Chrissy drew this graph to show the percentage of buses that got to a bus stop on time for 6 months. So in January there were like about 76%, February there was 78%, March there was 86%, and so forth. Now with a scatter graph, you never join the points together. That's a line graph, so we don't want to do that. So what's one thing that is wrong with the graph is they have joined all the points together with a line. So everything else is right. So she's got 10, 20. Oh, also you might want to check the axes. It should have been 10, 20, 30, 40, 50. That your axis needs to go up in even intervals. So that's one thing. Or you could have said the 30 is missing on the y-axis, and that might be a bit more of an obvious one. And you need to describe the trend in the percentage of buses that got to the bus stop on time. So generally there's a positive correlation. So if you draw a line of best fit for your scatter graph, it's just the line going through as many points as positive. So there's a positive correlation, and you could explain it in a bit more words if you wanted to. The percentage increases, the percentage of buses on time increases as the months go on, as it gets warmer. Maybe people are happier, so you know, so percentage increases as the months go on. Okay, now here I've got a bearings question. So I'm told here is a map of an island and the diagram is drawn accurately. So a straight road joins the 2 villages, Backley and Cremford, and I need to work out the real distance between the 2 villages. So what I want to do, here I've got Backley, here I've got Cremford. I'm going to get my ruler and measure this line. Okay, so if you've got the paper printed out in front of you, put your ruler starting on 0 and then find out the exact point where it stops, and you should get around 5.5. You might be 1 or 2 millimeters off, but 5.5 is the measurement of that line on the piece of paper. So I know that it's 5.5 centimeters, and I'm told here they're always going to give you a scale. I'm told that 1 centimeter is equal to 0.5 kilometers. So for every centimeter, it's 0.5 kilometers. So I want to find out how many 5.5 centimeters would be. So what do I do on my map? For each centimeter, I'm going to times by 0.5, because how do you get from 1 to 0.5? You multiply by 0.5. So if I multiply by 0.5, I'm going to get my real distance. So 5.5 times by 0.5 equals 11 over 4. So remember, if you get a fraction, you can press the format button and decimal, which is not the most convenient of things. You used to have the SD button, but hey. Then it's 2.75 kilometers in real life. So we'd write that down. For the next question, it's saying find the bearing of Cremford from Beckley. All the bearing means is, in this question, it's not such a difficult one, but you're trying to work out what the angle is from due north to your other thing. So let's go through it bit by bit. So find the bearing of Cremford from Beckley. This is very important because when you start dealing with bearings, always start from the place it says from. So it's saying find the bearing of Cremford from Beckley. So I'm going to start from Beckley. And whenever you measure your bearings, you always start, you always put a straight line up and you measure it from due north, which just basically means up. So I'm going to start measuring it from here is what it means. And you measure it until you get to the line. So Beckley to Cremford, your line is over there. So essentially what it means is you want to measure this turn. So your due bearing up north would be 0, 0, 0. Bearings are written in 3 digits, but if you've got a 3-digit angle, you don't need to worry about that. So you get your protractor, you measure this angle here, and this angle is 130 degrees. So the bearing of Cremford from Beckley is 130 degrees. Bearings are a bit of a tricky one, so watch the video on bearings separately to try and understand it more fully. Okay, next this shouldn't say distribution, this is a shapes on a square grid question. I've shown 2 shapes drawn on a centimetre grid and I'm told to find the area of shape P. So there's 2 ways you can do this. You can either count the squares or you know it's a triangle, and the area of a triangle, to work it out, you do the base times by the height, and it's always the perpendicular height. Perpendicular means at right angles to. So basically this would be the base and at right angles to it would be this way. So the height would be this length here and the base would be this length here. So the base is 1, 2, 3, 4 squares. The height is 1, 2, 3, 4, 5, 6 squares. And I'm going to divide that by 2. Base times height divided by 2. You can do it on a calculator. It'd be 24 divided by 2, which is 12 centimetres squared. And I say it's centimetre squared because I know that it's a centimetre grid, which means each of these squares is 1 centimetre squared. Or you could count the squares, but it's a little bit trickier. I would say the easiest thing is to just work out using the formula for the area of triangle. But you've got 1 square here, 2, 3, 4, 5, 6. And then you could think which ones you could pair together. But I'd actually say that's a much trickier way to do it. So just use the formula for the area of a triangle, which is base times by the perpendicular height divided by 2. And then I just need to write down the mathematical name of quadrilateral Q. So this is a kite, and the properties of the kite are that it has 2, it's a quadrilateral, a 4-sided shape. It's got 2 equal sides here and 2 equal sides over there. And you know your other quadrilaterals would be a trapezium, rectangle, or a parallelogram. So when it looks like this and you know that these lines are longer, that's when it's a kite. Okay, so now I've got a question. I've got really itchy. The table shows a cricket club's income in 2016 from a fete, a quiz and membership fees. And a fete is like a fair, if you didn't know. And I need to express as a ratio the income from the fete. So sometimes they put in words that not everyone is going to know, but yeah, it's like similar to a fair, or it's where you get together and you celebrate and there are stalls and things. So express as a ratio the income from the fete to the income from the quiz to the income from the membership fees. So I know the fete is 250 income. The entry fees were 13 people came at £5 each. So I'm going to have to do 13 times 5. Oh, 13 times 5, which is 65. So for the quiz, they made £65 from the entry fees plus £35 from the refreshments. So I'd do 65 plus 35, which is 100. So 100 in total from the quiz. And the membership fees, they had 25 members at £20 each. So whenever it says it's something each, that means per person. So you're going to multiply to work out the total. So 25 times by 20 is 500. So once again, it's ratio. So you need to express as a ratio the income from the fate. So I write the fate first, to the quiz, to the membership fees. So I'm going to write 250 to 100 to 500, and it says give your ratio in its simplest form. And just like when I'm simplifying fractions, I can just divide each little ratio by the same number and it will simplify it. So the easiest thing to do might be to divide by 10 to just simplify everything first. So if I divide by 10, I can basically just chop off that 0. So it's 25 to 10 to 50. And also when you're simplifying, you don't want to have decimals. That's why I couldn't divide by 100. So now let's think, does any other number go into this? I could divide that by 5 as well. So 25 divided by 5 is 5, 10 divided by 5 is 2, and 5 divided by 5 is 10. And I can't simplify it any further, so the ratio in its simplest form would be 5 to 2 to 10. I'd always say when you're simplifying with ratio, start with a nice number like 10, 5, 2. If you tried simplifying it by 2, you could keep going. It doesn't matter how many times you simplify it, as long as you get there in the end. Okay, here I've got a frequency tree. So these are actually quite simple if you just know what you need to do in them. So with a frequency tree, the key thing is that these things need to add up to make your total. So here's your total, your original amount, 200 people will live in the village. So these two things, this plus this, and then also this plus this plus this plus this, the total of them must add up to 200 because you're just splitting up the 200 into separate parts. So if you know that, and you always double check that each of your almost like columns add up to 200 or the total, then that will be really great and really helpful. Then you use the information that you're given. So we're told that 23 people do not have a garden. So I look at where it says do not have a garden, and I'm going to write 23. Now, if I know that my total of this plus this must be 200, I can do 200 to take away 23 to figure out how many must have a garden. So 200 take away 23 gives me 177. So I know that my total columns must add up to the total, and then also each little branch needs to add up to what it came from. So these two branches came from 200, therefore they must add up to 200. Then I've got these two branches over here, and because they've come from 23, these two things need to add up to 23, and then these two over here are going to need to add up to 177. So the total of these two is going to have to be 23, and this is going to have to be 177. So it just helps to know that. Then I'm told that 10 males do not have a garden. So I go to do not have a garden, and I go to male, and I'm going to write 10. And I know that it must add up to 23. So I can do 23 take away 10 to figure out how many females must not have a garden. And then I'm told that 95 people are male. So in total, where's your males? You've got male here and male there. And you know that these two must add up to make 90. Is that 95? 95. So 95 take away 10 is 85. So I can figure out how many males must be here. And I know that these two must add up to 177. So I can just do 177 take away 85, which is 92. That's how I do the frequency to double check it. I just want to double check that my things add up to 200. So 23 plus 177 is 200. And then 10 plus 13 plus 85 plus 92 equals 200 as well. So that's how you know you've done it right. Then it says, one of the people who does not have a garden is chosen at random. So how many people do not have a garden? 23. So that's going to be my total, because it's not saying one of the people in the village, it's saying one of the people who does not have a garden is chosen at random. So that's how you decide what your denominator is. It's going to be out of 23. Write down the probability that this person is female. So 13 over here, 13 out of the 23 people that do not have a garden are female. And whenever you're doing probability, you just literally, your denominator is the total of the thing that you're talking about, and the numerator is the thing, in this case female. Okay, so this one is a rate of pay question. So rate of pay is essentially the same as your hourly wage, how much you get paid per hour. So Annie makes hats. She makes at least 17 hats per hour, and she is paid 46p for each hat that she makes. I don't know how you say his name, but Riaz is a waiter. He works 35 hours and is paid a total of £266. Show, so whenever you have a show that question, it means you show every tiny little step of your working. Show that Ellie's hourly rate of pay is more than Riaz's hourly rate of pay. So let's start with Riaz. So his is simple, because his hourly rate of pay is, to work out the hourly rate of pay, you do the total pay divided by number of hours worked. So that's how, when you first start having a job, you can work out what your total pay is, divided by how many numbers of hours you work, and that will tell you how much you get paid per hour. So Riaz, his rate of pay is going to be 266, which is his total, divided by 35. And if we do that, we've got 266 divided by 35 gives me 7.6. So 7.6, if I turn it back into money, is going to be £7.60. Then I need to figure out what Ellie's hourly rate of pay is. So she makes at least, so this is a little bit of a not a great worded question, because, you know, if she makes 20 she'll get paid more, but let's just go with the basic. If she makes at least 17 hats per hour, that means that in 1 hour she's going to get paid for those 17 hats, and she gets paid 46 pence for each of them. So 17 times 46 is going to tell me how much she gets paid. How much money she makes in an hour. So that's 786 pence, because I'm still working in pence. To turn it back into pounds is £7.86. So therefore, Ellie's rate of pay is more, because £7.86 is greater than £7.60. So for this question, it's very important you showed both of their rates of pay and compared them. Okay, here I've got some algebraic reasoning. So I'm told that A and B are odd numbers. Give an example to show that the value of 2 brackets A plus B is a multiple of 4. So I need to give an example, which means you can literally pick any odd number in the world. So let's say that A is 3 and B is 5. So I'm going to write that like this: 2 brackets A plus B is going to be 2 brackets 3 plus 5. Now, there's 2 ways you can do this, depending on what you feel best with. You could have expanded the brackets first. So let's just stick with A is 3 and B is 5. So expanding the brackets means multiplying the number on the outside by each term on the inside. So 2 times A is 2A, 2 times B is 2B. And remember, when a number and a letter are next to each other, it means they're being multiplied. So that's the same as saying 2 times A plus 2 times B. And if I say A is 3, 2 times 3, and B is 5, 2 times 5, then 2 times 3 is 6, and 2 times 5 is 10. 6 plus 10 is 16. So that's an example to show that it's a multiple of 4 because 16 divided by 4 is 4. Your second way of doing it is if you want to just substitute them into the brackets first of all, and then using BIDMAS, we know we do whatever's in the brackets first. So 3 plus 5 is 8. And when we've got brackets, it means whatever is on the outside we multiply. So 2 times 8 is 16. And once again, 16 divided by 4 is 4. So the key to this question, it looks quite tricky because it's worded with algebra, but just read what the question is saying and take it literally. A and B are odd numbers. Give an example. So pick some odd numbers. You could have picked any odd numbers. You could have picked 17 and 19, but 3 and 5 are quite simple. Okay, so in this question, I need to show that when A and B are both odd numbers, that the value of 2 brackets A plus B will always be a multiple of 4. So to do that, I know that A plus B is going to be an odd number plus an odd number. And you can try this. So like 1 plus 3 is 4, 3 plus 7 is 10, 17 plus 3 is 20. Just try any two numbers. An odd number plus an odd number always makes an even number. So you need to make it clear that an odd number plus an odd number always makes an even number. So that's a statement 1. And then what does it mean? So A plus B is always going to be even. And if A plus B is always going to be even, what else do you have? Well, 2 times by A plus B is therefore, and these 3 little dots just mean therefore. They're not necessary to use, but they're just a bit of fun. So is therefore going to be 2 times by an even number. And 2 times by an even number is always going to be a multiple of 4. Because if you think about it, any even number, so let's say 6 times 2 is 12, 12 is a multiple of 4. Pick another even number, 30 times 2 is 60, 60 is a multiple of 4. So because I'm doubling something and 4 is double 2, that's why it's a multiple of 4. But it is quite tricky. These algebraic reasoning questions are difficult. Okay, so this is quite a worded question, so it's very important to read these worded questions carefully and try and extract as much information as you can from them. So we're told that Mr. Page uses oil to heat his home, and that at the beginning of November there were 1,000 litres of oil in his tank. So sometimes it helps to just like draw a little picture to just visualise it. So he had 1,000 litres at the beginning of November. Mr. Page bought enough oil to fill the tank completely. So we don't know the full amount of the tank, but we know that when he bought this oil, it filled the tank completely. He paid 50 pence per litre for this oil, and he paid a total amount of £750. So basically £750 is the number of litres that he got times by 50 pence. So to work out what the number of litres are, we'd do 750 divided by 0.5, because I've just turned 50 pence into pounds, which would be 0.5. So 750 divided by 0.5 is going to tell me the number of litres he must have bought. So 750 divided by 0.5 is 1,500 litres. So another 1,500 litres helps fill up the tank till full. So that must mean that the tank has a capacity. Capacity just means how much liquid you can hold. So it can hold 1,000 plus 1,500 litres. So in total, the tank has a capacity of 2,500 litres. It can hold 2,500 litres in it. So what are we told next? At the end of February, Mr. Page had 600 litres of oil in his tank. Okay, so he bought enough oil to fill the tank completely. So we know that if he had 600 litres left, 2,500 take away 600 is 1,900. So that must mean to fill the tank back up, if it got back down to 600, we know the total amount is 2,500. So we'd have to do 2,500 take away 600 to figure out how much is left to need to buy. So he needs to buy 1,900 litres to fill the tank back up. The cost of oil had increased by 4%. So 4% increase. The original cost was 50 pence. Now to do a percentage increase, there's loads of ways to do this, but the quickest way is probably to use the multiplier. So when I'm trying to work out a percentage increase, what I want to do is I always start with 100% because that's the amount, the original value. So 50 pence was the original value, and I want to increase it by 4%. So 100% plus 4% gives me 104%. And what does percentage mean? It means out of 100. So that's the same as saying 104 out of 100, which is the same as saying 104 divided by 100. And therefore I end up with a multiplier 1.04. So a 4% increase is technically you're working out 104% of the amount. So you could do 50 times by 1.04 to work out what the new price would be. So 50 times by 1.04 is 52. You could also have gone down the route of working out 1%. So to work out 1%, you divide by 100. So 50 divided by 100 is 0.5. And then 4% is going to be 4 lots of that. So 0.5 times by 4 is 2. And then added that on to 50. So you choose which method works best for you. But a 4% increase would end up being 52 pence for the oil. So I know that his new price for the oil is 52 pence. And I know that because he only has 600 litres in it, he needs to buy 1,900 litres. So I'm going to do 1,900 times by 52 pence. So 1,200 times by 52 is 62,400 pence. And now to turn pence into pounds, I divide by 100 because 100 pence gives me £1. So to go from pence to pounds, I divide by 100. So that would be 62,400 divided by 100 is going to be £624. To divide by 100, you chop off 1 0 to divide by 10, chop off 2, you've divided by 100. Only if the end of your number ends in zeros. So that's what he would have done for February. Okay, so I've just looked at this question again and I don't know what I typed into my calculator, but it's definitely not this. So 1,900 times by 52 is 98,800. So divide it by 100 to turn it into pounds is going to be 988 pounds. So sorry for the confusion that might have caused. Okay, now I have got a double-sided equation. So I'm solving. Solve means find the value of x. So basically get to the place where x is on its own on one side of the equation. There's lots of ways we can do this, but let's have a look at what's going on. So you've got 5x take away 6 equals 3 brackets x minus 1. So the best way to do this, if you see brackets and you've got a complicated algebraic expression, expand the brackets first. So how do you expand a bracket? You multiply the number on the outside by each term on the inside. So on this side, I'm not touching it because I'm only expanding on this side. So 3 times x is going to be 3x, and 3 times -1 is going to be -3. So now I have a two-sided equation, and whenever you have x on both sides, there's a little trick that we always use. We move the smallest one to the other side by subtracting. So if I take 3x, I've basically cancelled it on this side of the equation, and whatever you do to one side of the equation you have to do to the other, which is why I'm taking away 3x from here as well. So 5x take away 3x would leave me with 2x minus 6 equals negative 3. You keep everything else the same, you're just subtracting 3x from 5x. And then we've got a one-sided equation, sorry, a double-sided, we've just got a normal equation, a two-step equation. So there's a few ways you can do this. If you like the balancing method, you can do that. I'm going to show you the flowchart way as well, just to help you. So when we have an equation, you always start by thinking what's happening to the x. So I've got my x over here. The first thing that's happening to it is it's being multiplied by 2. And then I'm subtracting 6 from it. And what comes out is negative 3. So using the flowchart, you can just work your way backwards by doing the inverse, and then you end up figuring out what x is. So the opposite of minusing 6 is adding 6. So minus 3 plus 6 is 3. And then we're going to have to divide by 2 because we're doing the inverse. So minus 3 plus 6 is 3, and 3 divided by 2 is 1.5. Or you could write it as 3 over 2. So that's the flowchart way. If not, then you use the balancing method. So we think to ourselves, okay, we've got 2x on this side. Oh, why is that gone? The first thing I want to do is remove anything else that's on that side. So I've got a negative 6. I'm going to have to add 6 to cancel it out, because minus 6 plus 6 is 0. And whatever I do to one side, I do to the other. So I end up with 2x equals minus 3 plus 6 is 3. And the next step, I know that 2x means 2 times by x, so I'm going to divide by 2. So x is going to be 3 divided by 2. Therefore, x is 1.5. And obviously you have a calculator, so you could have just typed it into there. Okay, so here we've got a percentage profit question. So I'm told that Emily buys a pack of 12 bottles of water, and the pack costs £5.64. She sells all 12 bottles for 50p each, and I need to work out her percentage profit. So to work out the percentage profit, I have to use this formula. So to work out the percentage profit, you're working out the difference between your new value, take away your original, you divide that by your original amount, and you times it by 100. So my new value, she has sold all 12 bottles for 50p each. So 12 times 50 is 600p, which is £6. So her percentage profit is going to be the new value, which is £6, take away the original, which is £5.64, divided by the original value, and then I times it by 100. So you've got a calculator, so we can use the fraction button once again over there, and we type in 6 take away £5.64 over £5.64, which gives me 3 over 47, and then I just times that by 100, which gives me 300 over 47, and then you can press the format and the decimal number to give you 6.382978. Going on, it says give your answer correct to one decimal place. So I'm going to look at the first decimal place, look next door. If the number's 5 or more, it means I'm going to round it up. So that would be 6.4 to one decimal place. Okay. Here I am told that Hasmi walks once around a circle with a diameter of 80 meters. So essentially, if she walks once around it, she's walked all the way over here. And I know that the diameter of this circle is 80 meters. So the diameter is the line that goes from one side of the circle to the other, and it goes straight through the center. And that has a length of 80. So that means that the line from here to there is going to be 80, or from here to there, or from here to there, or from here to there, basically from any edge of the circle to the other. So there are 8 points equally spaced on the circumference of the circle. Find the distance Hasmeet walks between one point and the next point. Okay, so she walks all the way around the circle. I know that the circumference of the circle is the perimeter of the circle, so the distance around the outside of the circle. And there's a special relationship between the circumference and the diameter. Basically, for any circle, whatever the diameter is, the circumference is always going to be roughly 3.14 times that. And that number is pi. It's just a relationship. If you unfolded the circle, whatever the length of the diameter is, the whole circumference is going to be 3.14 times that amount. So I know that my diameter is 80 meters, and I can work out the circumference by the formula. And this is a formula that you're shown on your formula sheet. So the circumference is pi d, which means pi times the diameter. It might also sometimes be shown as 2 pi r, because 2 lots of the radius, so the radius is from the center to the outside, 2 lots of the radius is the same as 1 lot of the diameter. So to work out the circumference of a circle, I'm going to do pi times 80. And I type that into my calculator. It will probably simplify it to shift. So to work out what pi is, first of all, you're going to press the shift button. And then every calculator is different. And this one, you basically want to get to the point where you see a little pi symbol. Pi looks like this on your calculator. It's very important that you locate it so that you know where these things are. So pi times 80, as you can see, is going to just give it to you as 80 pi. So once again, you press the format button and then you convert it into a decimal. Or if you're lucky and you have the old calculators, you just press SD. So that's going to be 251.3274123. So that is the distance around the whole of the outside of the circle. And I need to find the distance she walks between one point and the next point. So there are 8 points altogether. So if I know that the full circumference, I unraveled it, or even just looking at here, I know that this is 251.327. And I want to split that into 8 equal parts. Because once again, if I unraveled it, and here's A, and then you've got B, C, D, E, F, G, H. They are all equal parts. So I know that this whole length is 251. So I'm going to do 251 divided by 8. That's going to tell me the distance between each point. Divided by 8 is 10 pi. Once again, your calculator automatically does that. So you do format decimal, and that is 31.41592654. It hasn't actually asked us to round to anything, so you can just write out the full amount, or you could round it to 2 decimal places, which would be 31.42. Then I'm told that 4 of the points are moved, as shown in the diagram below, and she walks once round the circle again. Has the mean distance that Hasmeet walks between one point and the next point changed? You must give a reason for your answer. So how do you work out the mean? The mean, if I just had like some normal value, so let's say she walked along a line that was 10, and let's say it had 3 points, and originally there was a distance of 1, a distance of 2, and then a distance of 7. How do you work out the mean? You add all the values together and you divide by how many numbers there are. So in this case, it would be 10 divided by 3, which is 3.3 recurring. So that would just be an example. Now, if I change the distances, and let's say I made it a distance of 4 and 4 and 2. I work out the mean. I'm going to do 4 plus 4 plus 2 divided by 3. What's 4 plus 4 plus 2 going to mean? It's going to be 10 divided by 3, which is the same thing, 3.3. The mean is unaffected because the total distance between the points, it still adds to the same thing. So my original circumference for this thing was 251. So the original length was 251.327, and I had an average distance of 31.42 because they were equally spaced. So if I did 8 lots of 31.2, it still adds to 251.27. Now this distance has changed, so it might be a little bit bigger. This one's smaller, this one's a bit more, this one's a bit less, this one's a bit more, this one's a bit less, this one's a bit more. But if I untangled that circle, it's still going to end up being 251.327. So regardless of whether it's a distance of 31 still, or if it's a distance of 50 and then 2, your total is still going to be the same, because the mean is you add your values together divided by the number of values that you have. We still have 8 values, so we're still going to end up dividing by 8. And I know that whatever the distance is, it's still going to end up being 251.327 as the circumference stays the same. So what's the reason? We could say the mean distance has not changed as the total of the distances walked is still 251.327, and there are still 8 values. So the mean will remain the same. These reasoning questions are actually, I think, personally, the hardest parts of a GCSE, because they require you to really understand the mathematical knowledge, to really think about it, and to explain yourself. So hopefully you kind of understand how you'd go about doing that. Okay, next we have a probability question. So there are only blue cubes, yellow cubes, and green cubes in a bag. So we've got blue, yellow, and green. And I know there are twice as many blue cubes as there are yellow cubes. So because I'm doing everything in reference to the yellow cubes, I could call my yellow cubes X, an unknown value. I don't know what their amounts are. Whenever you don't know something, you just use algebra. So whenever you have an unknown, just call it X. X could be 200, it could be 2, it doesn't matter, but I can create a relationship in relation to that. So yellow cubes is X, an unknown amount. I know that there are twice as many blue cubes as yellow cubes. So there are twice as many, which means timesing by 2. So 2 times X would give me 2X. And then I'm told there are 4 times as many green cubes as blue cubes. So if blue cubes, there are 2X. There are 4 times that. That means I'm doing 2 times X times 4. When I'm multiplying algebra, I multiply the numbers. And then I've got times by X, which would become 8X. Now Hannah takes at random a cube from the bag. So the total amount of cubes would be all of my cubes added together. So I add my expressions together. 2x plus 8x is 11x. So that's going to be my total. And whenever I do probability, remember your denominator is your total. And I want to work out the probability that Hannah takes a yellow cube. So the expression for yellow was X. So I've got X over 11X. Now, when I write probability, I want to write it, I'm not sure, they might accept this, but I think they would want you to simplify it. So whenever we're simplifying fractions, let's just have a look. So we've got x over 11x, and x on its own, what that actually means is one lot of x. So whenever you've got a fraction and you have something on the numerator and the denominator, and it's not separated by an addition sign, so when it's just one term, you can just cancel it. So 1x is the same as saying 1 times by x, 11x is the same as saying 11 times by x. So this is just one term, it's connected by multiplication sign, which is fine. I can just cancel it because x divided by x is 1, because anything divided by itself is 1. So if you have the same thing on the top of the fraction as the bottom of the fraction, it cancels out. So that would just be 1 over 11. I'm not sure, because I haven't looked at the mark scheme yet, but you might get it if you get x over 11x. If not, then it's 1 over 11. And the way to simplify it is just by realizing, okay, I've got x on the top and the bottom, so I can cancel them out. Okay, over here I've got a transformation question. So I need to rotate trapezium T 180 degrees about the origin. Now the origin is literally the center over here. It's 0, 0. The origin is where everything begins. So I need to rotate T 180 degrees about the origin. And when I do this, you get some tracing paper. And when you rotate, you always go clockwise. In this case, it doesn't matter because 180 will take you both ways. But you put your tracing paper. So this can be your tracing paper. You get your pencil and you draw over this shape. Then you put your pencil here and you rotate the paper. So if this is how your paper starts off, when you rotate it, it's going to look like this because you're rotating it clockwise. That's a 90 degrees rotation. When you rotate it again, it's going to look like this. That's going to be a 180 degrees rotation. So when you've done that with your tracing paper, you want to generally, the safest way is, some people are really good at remembering, but you might want to just note down where the new points take you. So your trapezium on your tracing paper, you should see this outline here and you'd be like, okay, so one of the coordinates is -2, 1. Let me write that down. The next one is -2, 2. Then you've got -4, 1. And then -5, 2. So write down your coordinates and then you can draw your lane shape on. So let's label the trapezium A. The next question is saying translate. So translate, that means move. Move it through the vector. And it's telling us the vector -1, -3. So your vector is a movement and your top part of the vector is the movement across. So your x coordinate, or how much it moves across along the x-axis, and the bottom number is how much it moves up or down. So if it's going left, it's going to be negative. If it's going down, it's going to be negative. If it's going right, it's going to be positive. If it's going up, it's going to be positive. So I've got -1 for my top x movement. So that means 1 to the left. So negative means I'm going to the left. And I've also got a -3. So that means 3 down. So what I do is I can pick any point of my trapezium. I can just pick this top point. I know I need to move, it's going -1 and then moving down 3. So across 1 and then down 3. So I go across 1 and down 3, and that is where my new point would be. I can then just by looking at it, draw the whole trapezium, or I could do it point by point. So over here, I go across 1 and down 3. Same here, I go across 1, down 3, across 1, down 3. And that's how you translate a shape. So it's really important that you know that the top value is your x movement, how much it moves across. If it's negative, left, positive, it goes right, and the same for the second part. Okay, over here we've got some index laws. So the key thing that we need to know is when we're multiplying indices, so let's say you've got 2 squared times by 2 to the power of 3, that ends up being 2 to the power of 5. But why does that happen? When I am multiplying indices, I always add the powers together. I mean, 2 squared means 2 times 2, 2 cubed means 2 times 2 times 2. So in total, 2 is being multiplied by itself 5 times. That's what this little power means. It means how many times your base, the big number, is being multiplied by itself. So here I'm multiplying my indices. So I know that p to the power of 3 times by p to the power of x. What am I going to have to do when multiplying indices? You add the powers. So what would I have to do? That would become 3 plus x. I don't know what x is, but I know that p to the power of 3 plus x is the same as p to the power of 9. So I can then form an equation. I know that 3 plus x must be equal to 9. So 3 plus something equals 9. If I take 3 from both sides, x is 6. So this is quite a tricky question, but it's about using the laws of indices that you already know, or if you didn't, then familiarize yourself with them and applying them. And then a little tricky bit, recognizing that they must be equal. The same thing here, when you're multiplying indices, so let's say I had 7 squared times by 3, that would become 7 to the power of 6, because when indices are in brackets, this is the law of brackets, you multiply the powers. The powers are just the little numbers. So that means 7 squared to the power of y would become 2 times by y, which is 2y. So I know that 7 to the power of 2y is the same as 7 to the power of 10. So therefore, 2y must equal 10. And if I divide both sides by 2, y equals 5. You could also have maybe just done that without drawing these equations. If you know the laws of indices, you're like, okay, I know that I'm going to have to do 3 plus something to make 9, 3 plus 6. And over here, I know I'd have to do 2 times something to make 10. But this is the reasoning bit for it. Okay, show that 100 to the power of a times by 1000 to the power of b can be written in the form 10 to the power of w. So this is quite a difficult question. There's no two ways about it, but let's have a think about what's going on. We've got 10 to the power of w. That's how we want to write it. We want to write this and this in the form 10 to the power of something. So how could I write 100 in terms of 10? I know that 10 times 10 makes 100, and to write that in index form would be 10 squared. So 100 to the power of a is the same as saying 10 squared to the power of a. All I've done is I've rewritten 100 as a power of 10. And using the laws of indices, what do I do when indices are in brackets? I multiply them. So that would become 10 to the power of 2a. So all I've done is I've rewritten 100 to the power of a as 10 to the power of 2a. Now I want to do the same with 1000. So 1000, well, let's just do 1000 first. 1000 is the same as 10 times 10 times 10, which is the same as 10 cubed. So the trick here is looking at it and being like, okay, how can I write 100 as a power of 10? How can I write 1000 as a power of 10? So 1000 to the power of b is the same as saying 10 cubed to the power of b. And once again, what do you do when you multiply indices? Indices are in brackets, you multiply them. So that would become 10 to the power of 3b. So 100 to the power of a times by 1000 to the power of b is the same as saying 10 to the power of 2a, following this route, times by 10 to the power of 3b. So therefore, if I write that out like this, I know that 10 to the power of 2a times by 10 to the power of 3b is equal to 10 to the power of w, because what happens when you multiply indices, you add the powers. So that would become 10 to the power of 2a plus 3b is equal to 10 to the power of w. And then what do? I know that this must be equal to that, so therefore w must equal 2a plus 3b. This is a tricky question, but that's how we'd show that, so we'd show all of that working. Okay, so now we've got a trigonometry and context question. So I'm told that ABCD is a trapezium, and I need to work out the size of angle CDA. So when you're trying to figure out where the angle is, you follow the line. So you start from C to D, and then you go to A. So the angle is whatever angle is in between those two lines. So therefore it's this angle that I need to work out. So I need to work out that angle, and I need to give my answer correct to one decimal place. So let's have a look at what I need to do in order to work out that angle. Well, I know that this length over here is 6. So whenever I need to work out an angle, I always know that I'm going to use trigonometry, essentially. So that's the first thing that might come to your head. In order to use trigonometry, you need to have a right angle triangle. So how can I create a right angle triangle over here? Well, if I know that this length here is 6 centimeters, this length here must also be 6 centimeters, and that could be the height of my triangle. So then I've got this triangle here. I have this length. I need to work out this angle, and there's probably some other things that I could figure out too. So what I'd need in order to figure out this angle is this side here, or the diagonal, but I feel that this side would be easiest to work out. So I'm going to have to do quite a few steps and just look at the shape and think, what can I figure out from all of this? I know that this is a rectangle, and if this line is 10, this line here must also be 10 centimeters. And I know that over here, I've got a triangle with quite a bit of measurement. So I've got 6 centimeters here, 7.5 centimeters here, and I don't know what this length here is, but it's a right angle triangle shown by this little thing here. And I can use Pythagoras to work out the missing side. So Pythagoras is a squared plus b squared equals c squared, and essentially c is always going to be the hypotenuse, your longest side. So if you've been given your longest side, you're going to have to do a subtraction. So c squared minus a squared equals b squared. So what would I do? Well, the value of c is 7.5. So I'd write 7.5 squared, take away 6 squared, and that's going to give me this length here squared. So let's write that into my calculator. 7.5 squared, take away 6 squared, gives me 81 over 4, which is 20.25 equals b squared. And when I'm trying to get the inverse of squaring is square rooting. So I'm going to do the square root of 20.25, and that gives me 4.5. So b is 4.5 centimeters. So I'm just trying to work out as much information as I can. So I now know that that's 4.5 centimeters. This length here is 10 centimeters, and the total length is 24 centimeters. So to work out this part of the triangle over here, I could just do 24 take away 10, take away 4.5, which gives me 19.2. So let's rub all this working out. That was prior working. And I now know that this, what? So 19 over 2, sorry, which is 9.5. So now I've got a right angle triangle and I can figure out what the size of angle CDA is. So whenever you're using trigonometry, the first thing you should always do is label your sides. So you've got your hypotenuse, and your hypotenuse is always going to be the side that is opposite the right angle. Then this is your chosen angle that you're working with. So this is going to be the opposite side, and this is going to be the adjacent side. So with trigonometry, we write out SOHCAHTOA, and we think about which sides we're going to use. So we've been given this side, which is the adjacent, and also the opposite. So SO is the opposite over the hypotenuse, CA is the adjacent over hypotenuse, TOA is opposite over adjacent. So I've got adjacent and opposite, so I'm going to use TOA. So I write out my trigonometric statement. So tan theta is the opposite over the adjacent. So tan theta is going to be opposite 6 centimeters over 9.5. And to work out theta, we have to press the inverse of tan. So the way I do that on my calculator, I press shift and then tan. So you end up with something that looks like tan minus 1. So you're going to write tan minus 1, and you can write this as a fraction. Tan minus 1, 6 over 9.5, close the bracket, and you should get theta equals 32.27564, but it's to 1 decimal place, so I'm going to circle this, look next door, it's more than 5, so that would be 32.3 centimeters. Degrees. Theta is just the mathematical representation for the angle. And that's how we do that question. Okay, so here we've got a using a calculator question. So we just need to be familiar with our calculator. Now, all of this is inside a square root. So the first thing you're going to do is press your square root button, which looks like this. And then it's inside a fraction. So you're going to press your fraction button over here, which looks like that. And then we can enter everything in. So it says sine 25. So I press my sine button, 25, and I close the bracket. It's very important when we're dealing with trigonometry that we close our brackets. Plus sine 40, close the bracket. And then you use your arrows to go down, and you've got cos 25, close the bracket, take away cos 40, close the bracket. So that's what it should look like on your calculator. I don't know why the top is like being faded. There we go. So that's what it should look like. You press equals and you get, so this question, it is so important. Just like it says to you, write down all the figures on your calculator display, write down all the figures. So many people round them, but they want you to write everything down. So you write 2.75603957. And then it says, write your answer correct to 2 decimal places. So when I'm rounding to 2 decimal places, I circle the second digit after the decimal point, look next door. If it's 5 or more, I round up. So that would be 2.76. Okay, next we've got an equation with powers. So once again, when I'm doing anything algebraic and it looks a bit confusing, it's helpful to just bring it back to the basics and think about what it means. So 2x squared means 2 times by x squared. So I know that 2 times by x squared is 72. And I can use my function machine if I want to, or I can do the balance method. First thing I want to do, whenever you're solving, you can't imagine, like put your finger over the x, and anything else on that side we're going to do the inverse function of. So it's being times by 2. So the first thing I do is divide by 2 because that cancels this out. And I'm left with x squared equals 36. Then the inverse of squaring something is square rooting it. So I'm going to say that x is the square root of 36, and therefore x is 6. So that's the first part. Also, this is something that is so easy to forget. The square root of any number, you're always going to have a positive version and a negative version. So we'd say x is 6 or x is negative 6. Any square number, because negative 6 times by negative 6 is also 36, because a negative times a negative gives you a positive number. So this is something that people always forget. So if you can remember, the square root of any number could be positive or negative. I've got expanding double brackets. So a foolproof way of doing double brackets is using the grid method. You can use just the brackets, and if the brackets work for you, that's great. But just because so many people end up just making little mistakes on this, I would recommend using the grid method. So you write out each bracket, one bracket across, one bracket down. So you've got 2x plus 1, and then over here you've got 3x minus 2, and you just split it up like that. Then you're multiplying 2x times by 3x, and you can do any working out along the sides. So 2x times by 3x, what does that mean? 2 times 3 is 6, and x times x is going to give me x squared. Then you've got 3x times by 1, which is just 3x. 2x times minus 2 is minus 4x. So 2 times x times minus 2. 2 times minus 2 is negative 4. And then negative 2 times by 1 is negative 2. So what you've got is all of these terms. You write them out. So you've got 6x squared plus 3x minus 4x minus 2. And it's not just enough to expand. So this is what we've done. We've expanded the bracket. We're multiplying each term in one bracket by each term in the other bracket. And if you did the the arrow method, you'd still end up with this. And then it's our job to simplify. And generally, it's always going to be the middle two terms that simplify, the ones that have a coefficient to x. So 3x take away 4x, you can just use your number line. So if you had 3 and you're taking away 4, you've got 3, you're taking away 4, you'd go past 0, so that would be negative 1. So that would be 6x squared minus x minus 2. And then for the last question, we're factorising. So factorising is the inverse of expanding. And to factorise something, all we do is we're looking for the factors of the last thing in my quadratic. So factors of 9 would be 9 times 1 and 3 times 3. Factors are the numbers that multiply together to make them. And then what we want to do is, out of these factor pairs, decide which of them add to make my middle term. So 9 plus 1 is 10, 3 plus 3 is 6. So I know I'm going to use these two factors. Now what you do is you have the factor of 3 and the factor of 3. You put it into brackets and you're going to write x, and it's a positive 3, so you're going to write x plus 3, and over here x plus 3. So that's how you factorise, you putting it into brackets. You can always double check by expanding. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. Simplify it, x squared plus 6x plus 9, so you know you've done it right. But this is you expanding the bracket out. The answer is x plus 3, x plus 3. Factorise just means put it into brackets. And that's the end of that video. So hopefully that was helpful. If there are any topics that you want me to go over in more detail, let me know. And good luck with the rest of your revision.